Hi, my name's Keith Cooper from Northlight Images, and this is, as you can probably guess, about printing. In particular, it's about a particular piece of pernicious nonsense that gets spouted regularly about the importance of Dmax in papers. Dmax, it's effectively, there are technical definitions, but it's the blackest black you can make, and it's conveniently expressed in a number. Now, why am I returning to this? It's something I've covered and addressed many times before. It is because I'm just testing a new paper here. Now, this can't say it's not. It's a new paper from a supplier, and it's going to be announced next month. So I'm just testing it on a couple of printers. In particular, I'm testing it on the Epson ET8550, but I'm also testing it on the P5000 here. That's a pigment ink printer, and it's a 17-inch roll paper feeder, excellent printer that I use for a lot of larger prints. This is a cotton rag type paper, and I've printed it on, say, the 8550, which is a dye and one pigment black ink printer and the pigment ink printer. And in looking at the results, I realized that if you just casually look at the pictures, and this is just a test image I use for a lot of things, downloadable. I've got this linked via the reviews, and these are profiling targets, and underneath here is the device I use for making profiles. I'm using i1 Profiler software for this, and that's an i1 ISIS, so it reads these huge great patches in. But I've got lots of other stuff about that. But the thing is, if when making these, and I can see it in this light, even from here, which of these targets were printed on the 8550 and which ones were printed on that. Now, you might think, well, obviously that's several £1,000s worth of printer. The 8550, it's sold as an office printer. It's a very nice printer. You'd expect things to be better on that, particularly a rag paper like this. But in looking at these particular prints here, the casual observer who didn't know anything about pigment inks, longevity and things like that, might well decide that the ET8550 print looked better on here because the colours are slightly denser and richer. But surely it's an expensive paper, an expensive printer. Well, it's not that expensive a paper, I don't believe, but yeah, it's a good quality paper. Surely it ought to be better on that. And this got me back to looking at some of the numbers, because somebody recently asked me about this, and they said, well, I've been looking at two papers. One has a Dmax of something, and it's generally a number 1 point something, or typically 1.6 for matte papers like this, maybe 2 point something for glossy papers, and so it's a number. Now, unfortunately, it being a number means it's very usable for marketing purposes. And don't get me wrong, Dmax is not a useless bit of information to know. It is just something that not putting it in context can give you completely the wrong idea about a paper as to one paper is better than another. In fact, printing is such a personal thing that unless you're doing specific contract proofing or things like that, where you need precise measured colors and things like that, printing is about making prints that look good. Now, if you're selling your prints, it might also help for your marketing purposes if you can say, I printed these on an archival paper and I printed them with pigment inks. Pigment inks. I can even, if I want to add on the marketing pretentiousness, I can call them giclée prints. Anyone who writes to me and uses the word giclée in a non-ironic sense, who's seriously using it, I will point out that it's complete and utter nonsense. But that's marketing for you. This is not about marketing. This is about a subtle point about Dmax, the maximum density. Now, the particular example that I've got, that I've looked at, I'm going back to a paper I profiled on the 8550 a few months ago. And in looking at that, I've got the readings here that were taken when I was making a profile. Same sort of target as this. Now, because of the 8550, I made one profile using the Epson matte setting and one profile using the VFA Velvet Fine Art setting. The two are subtly different. I've done quite a few videos looking at the differences on that particular printer, but in this instance it doesn't matter particularly that it was this printer. I was just using two different media settings. And these are the results from i1 Profiler. And the classic way, I don't even need to read the numbers on this to know that this one is the matte setting, this one's the fine art setting, velvet fine art setting, because of the shape of a graph here. It shows me that dye ink was used here as the black. There's a little hook on it, because dye black inks are not as dark in the deep red and near infrared as pigments are. So you get a particular curve. But as I say, I've addressed this elsewhere. The numbers here, it gives me Dmax numbers. And in fact, when I look at these numbers, for the Epson matte setting, I have a Dmax, or maximum black, of 1.75. Now, I have on the other one, I have a Dmax, this is the VFA setting, same paper, same inks, just a different media setting. I have 1.67. Oh dear, 1.67V. 1.75. Surely this must be the better one, and that is the danger of it. And that's why if somebody says, "Oh, what's the Dmax of these papers?" and I say, "Why do you want to know?" It's all about context. Think of Dmax of the maximum speed of a car. This one is 167 miles an hour. This one's 175 miles an hour. Does it make any difference, that actual maximum speed, or is it the performance on the way? Anyway, what I'm going to show here is a gamut volume. And remember, gamut volume is another spurious number, beloved by some people, is a boundary condition. It shows the range of colours that profile, that paper on that printer at that media setting gives you. I'm using the Mac Soft Color Sync utility here to look at this shape. Now, bear in mind these are for illustrative purposes only, and I've picked the Velvet Fine Art paper here, and you can see this is looking down from the top, and you can see there's a certain range of colors. Now, if I look again at this shape, just have a quick check at the matte setting. It's different. Now, turn this around, and you can see it's a solid volume. But look at this bottom area, is relatively narrow. Those are the dark colours. And you can see all the other colours on it, and I can rotate it. These look pretty. This is why people include them in graphs and various stuff. If I now go to the VFA setting, there's a slight change from the top, not much, but look at the bottom. We've now got this extended shape. What does that mean? That bottom bit is dark colours here. So we're getting a much larger amount of dark colours. So, okay, well, the VFA one looks better. But this particular bit of software allows you to compare things. So I can hold one shape and then overlay the next one to have a look at it. But I'm looking here at the large shape of the VFA, and go back there, and I'm just going to hold that for comparison. Now, that was Epson matte, by the way. Go back to the VFA, and the two are overlaid. And we can see the bottom area here shows all the area where the VFA gives denser, richer colours. Yeah, great. If we look at the top, you can see that the Epson matte performs a little bit better in the very lighter colours. That's the top view of that there. And you can see that they're similar, but at the bottom end there, you're getting a lot more on the blacks, around the blacks there. Now, if I take it the other way round and just show the shape here, so we'll just go for the VFA. I'll hold that one. And now just go to the other. We can see a different version of a clearer view of the difference in gamuts between them. Now that looks very good. Great. VFA is obviously giving better looking colour, and that is what I noted with this paper. This is not necessarily true. But what's this little black bit at the bottom here? Now, if I zoom right into this one, I can see tiny little bit of black from one profile poking through. Now, that bit of black there, and it's the blackest black which it can do, is actually showing the Dmax. So we've got that tiny little bit of black on the bottom, which is the better Dmax here, the 1.75. Whereas we've actually got on the other one, at 1.67, the absolute peak of that little, how low it goes down, is less. So what you've got is a very confusing number, if you want. If you were just looking at that Dmax number, you'd go 1.67 v 1.75. Hey, look at the difference. Isn't one better than the other? So always be very wary of anyone who says, yes, well, I use such and such a paper. First of all, are they using the paper on the same printer as you? And it's always a difficult thing when people say, what's the best paper for my photos? Well, it depends on the printer you're using. It depends on the type of pictures you're printing. Now, I always use this particular test image because I know it very well. It has lots of features in it. So I'll put a link to the downloads for all the test images for this. But what we've got is an example here where, and I was showing this to someone the other day, and I hadn't spotted that little black bit sticking out of the bottom of the profile shape. We've got one here where dark colours, much better with the VFA, and it's noticeable in prints. But the absolute peak black, and the difference between 1.67 and 1.75 is minuscule. Now, on this particular paper that I'm testing, it's about 1.6 something on the 8550. It's 1.5 something on the P5000. That does mean, and that's why I can spot in this light, I can spot subtle differences between these targets. It's visible. There's no way I can show stuff like this on a video. It just doesn't work. Now, so there we go. Dmax. Next time someone tells you how wonderful a paper is and says, yes, the Dmax is such and such, compared, isn't this great? Yeah, it's like saying my car has a top speed of 175 miles an hour. Yours is only 150. Yours may be much more useful. It may be bigger. It may be a nicer car. It tells you nothing about the overall performance of it. So are there any other numbers you should be wary of? Yes, if you see somebody saying, well, this particular paper, and they start giving you DE values, and DE values are about variation of colour, and they try and express an accuracy for a particular paper, an accuracy of printing, and give a whole table of numbers. Always be wary when you see tables of numbers. But if they start showing things like that, be wary of it, because that's also data that doesn't necessarily matter. Likewise with gamut volumes and things like that. Remember, something like a gamut volume or something, which is that shape, and it's just a boundary condition, tells you nothing about what's going on inside. That boundary condition there, when people give you a gamut volume, they're giving you a measured gamut volume with their particular printer, that paper, their profile, and stuff like that. So it's very difficult to get meaningful data, information from it, from the data. Always be wary of the more tables of numbers you see in reviews, the more likely that those tables are there to convince people who like seeing tables of numbers. Now, if you expect to see tables of numbers and you like such stuff and you pore over details, then fine. All I would say is just put it in perspective. Just realize that there is far more to making great prints than the numbers. Now, I know some people will, certainly in commercial print, that's, I wouldn't agree with that in commercial print. But in making pictures of photos and printing your artwork, it's about the results that come. In the same way that the picture on the screen is but an intermediate stage, and you can never truly match a screen to a print, the print is what counts. If you're producing photos and producing prints, it matters not one jot what it looks like on the screen if the print works. And sometimes there can be differences. It depends on the papers, but I've covered that in loads of other reviews and videos. Anyway, hope that was of some interest and sort of cleared that one up. If you've got any questions, please do ask. I've deliberately not gone into the sort of technical aspects of measuring print density as to whether it's status T, status A, and all the various complexities are. This stuff can get very, very complex. And therein lies the danger, because people can just pluck numbers out of screens like this and go, yes, but look, this one is 11. 11 what? Doesn't mean anything. Anyway, thanks for watching. Bye.